All right, today we're going to be talking about residuals, and residuals are a comparison between the line of best fit and the scatter plot that was used to create that best fit, and how far those are from the actual value to the predicted value. So just a few key things to keep in mind as we're going through this is a residual is how far a point is. It can be above the line or it can be below the line. If the residual is positive, it is above the line because it's going to have a positive distance. If the residual is below the line, that makes it a negative number. So if the number is negative, it will be below it. And I'll keep referring to a line, but this could work for any best fit model. So what I'm going to do right now is we're actually going to look at this, doing some graphing by hand and calculating some things. And then we're going to look at it in terms of what Desmos can tell us. So I'm going to start by plotting my points and looking at what type of function I'm going to see here. Now looking at this, I should be able to, even with the small amount of scatter plots that we have, I should be able to determine that this is linear. And what we're going to do is we're going to find the best fit model for this equation. So in Desmos, we're going to put that table in, and you're going to type in your values. Be very careful as you're typing them in that you don't make a mistake with your numbers, because that can change your best fit, or line of best fit that you're trying to find. And you should see that the scatter plot looks very similar to what you have, and because it's a best fit model, we're going to use that slope intercept form, that y1. I call it a squiggle, but it's a similar mark, mx1 plus b. And it tells us that my slope and my y-intercept are, slope is 0.81 x plus 1.89. So we're going to round that. Now, what this is telling me, so if I were to actually draw this line of best fit, so I'm going to estimate here just a little bit. And if it were to go through here, just very similar to what's on the graph itself, the residual that we are getting ready to find is going to tell me the distance that each point is from that line of best fit. So that distance is going to be how good of a fit, and is actually in relationship to the correlation coefficient that was already discussed. So that distance, if it's above the line, is positive. If it's below the line, it is negative. So right now what we're going to do is we're actually going to put some information into our table. So the actual value is the value that we know that was given to us. Okay, so we know from the table my actual y values are that. I have -5, 1, 0, 7, and 4. Now what we're going to do is we're going to find the predicted values. So the predicted values are what we're going to get if we use the line of best fit. So if I take my 0.81 and I multiply that by my x value, I'm going to take here and we're going to put in -6. And my best fit model, it is predicting that I would have -2.97. Which obviously we should have gotten -5, but again, this is a best fit model. They're using the points given and they're fitting it the best that they possibly can. So if I were to do the same thing for -4, so my next example down here would be -4, and we plug that in the x spot, they're predicting that we're going to get -1.35. Now, if I continue this process on, and I did 0, obviously I get 1.89. Then I'm going to plug in 2. I get 3.51. And I'm going to plug in 5. These are all the predicted values that I would get. Now, in order to find the residual, the distance that my actual point is from the best fit model, or the predicted value, we're going to subtract the actual minus the predicted. The actual value minus the predicted value. So for my first one, I have the actual value here that we should have gotten for my y value is -5. We're going to subtract the predicted value. That predicted value is -2.97. And I got -2.03. So that means that that point, my actual point, should be approximately -2 units below the line of best fit. So if I'm looking at that point right here, okay, we have that -6, I can see that that is below that value. Okay, I could do the same thing with the next one. I would take my actual minus my predicted, and you should have gotten 2.35. So this is saying that that point, -4.1, is positive 2.35 units above that line, which it is above that line. Now, here's the great thing about Desmos. Desmos will actually tell you the residual. So if I'm looking at my best fit model that I've put in, I should see over here, you see it says residuals and it says to plot it. Now what it's going to do is actually going to plot points, but it's still going to give you the residual values. So if you go back to your table, I'm going to actually turn that plot off by clicking it, just because I don't want to see the points right now. I just want to see the residual value. So the first residual value, they got -2.02. Well, ours was a little bit off, but that's because we rounded our slope and y-intercept. They got positive 2.35 for -4.1. So then we have -1.89. We have 3.49. And we have -1.93. So let's do a comparison here. Alright, so this one, our first point right here on my graph, I have -6.5. That is a negative distance. That is correct, by about approximately 2 units. So this is -2.03. My next point was -4.1. That is approximately a positive 2.35 distance. At 0, 0, that is approximately a -1.89 distance. So you can start to see that these are all correct in where they are located from that line. So that one is a positive 3.4, and the last one is negative 1.93. All right, so in looking at that, why did we want to know this? Because we could look at things and we can determine the fit of that best fit model. So I'm looking at it and I'm determining, okay, which one of these values is closest to the predicted model. So the one that's going to be the closest is the one with the shortest distance. Now, it doesn't matter if it's above the line or below it, it's which one is the shortest distance. Well, the one that has the shortest distance, so which one matches this model the best, is going to be that 0, 0 model, because that one's the shortest distance. I'm now going to look at the residual plot. Mine wound up being the same color. I'm going to change that so we can see them differently. If we look at the blue values, what do those mean? Those are the distance that they are from the x-axis. So if I'm at -6, my residual is -2.03. So at -6, I'm going to do approximately 2 units down. That is the residual distance. This distance right here is -2.03. Alright, then at -4, my residual was positive 2.3. So this distance here is approximately 2.35. And you can see that that plot is happening the same way with the blue. If I turn everything off but the blue, we're getting that same plot. Alright, and then at 0, I have approximately -1.89, that distance from the x-axis. So the residual, again, is the distance above and below that x-axis when you do the residual plot in Desmos. I'm not so much interested that you are able to plot the residual. I'm more interested that you can interpret and analyze the residual. Okay, so I'm going to just finish this out, and we have at 2 the residual was approximately 3.4, so this distance here, and at 5 we have negative 1.93. So that's just giving you a visual of the distance there. Now, let's talk about an actual word problem for this situation. So it says, Ty did a project where he collected data that compares the age, X in years, of the students in Farmville to their height, Y in inches. Ty created a linear model that is represented, so they gave us the best fit. Ty's sister is 11 years old and has a height of 57 inches. What is the residual value? Okay, so to find my residual value, I need to do my actual value minus my predicted value. So what is my actual value? Well, we're talking about Ty's sister. Ty's sister is 11 years old and 57 inches. She is actually 57 inches tall. But we need to find the predicted value. So in order to find the predicted value, we're going to plug in what we know. And we know that she is 11 years old. So y equals 1.8 times 11 plus 37. All right, so back here I have 1.8 times 11 plus 37. So they're predicting that she should be 56.8 inches. So what is my residual here? Well, my residual is going to be 57, the actual height of Ty's sister, minus the predicted height of 56.8, and my residual is going to be 0.02. So their prediction here is pretty close to the actual height of Ty's sister. So I would consider this a very good prediction because the residual is close to the line. The further away your residual is, the less of a good prediction it is. The closer your residual and less distance you have, the better the prediction is. Okay? So the residual again is the actual value, the actual Y value, minus the predicted Y value.